So we start.
Good morning, sir.
Good morning.
Good morning, sir.
Good morning. Okay, so yesterday my last class. Okay, last class where are you? Probably we are discussing h of this part, right? N equal to
All পার্টটা হয়েছিল স্যার ইভেন্ট পার্টটা বাকি ছিল n is
হ্যাঁ
equal to u
তাহলে ইভেন্টটা করব আজকে সো ইভেন্ট পার্ট right this one n equal to 6 and we are using symmetric impulse response right. So symmetric impulse response, if we use hn equal to h of n minus 1 minus n equal to 6, then we have hn equal to say h0 up to h5 because n equal to 6 means 0 to 5. Okay, so h of e power j omega, h0 plus h1 e power minus j omega, h2 e power minus j2 omega, h3 e power minus j3 omega, h4 for n equal to 4, h4 e power minus j4 omega, h5 e power minus j. Now suppose if I have hn equal to h of n minus 1 minus n, that means n equal to 6, so hn equal to h of n minus 5. Now h0, if we put n equal to 0, so h0 equal to h5, and if we put n equal to 1, h1 equal to h of 4, and h2 equal to h of 5 minus 2 means h3, h2 equal to h3. Now what I am saying that h0 equal to h5, so I have to couple these two, and h of n minus 1 by 2, that will be equal to e power minus j5 omega by 2. Then if we take h0 common, so e to the power j5 omega by 2 minus e power minus j5 omega by 2. This is one part. Then h1 into this one, h1 into e power minus j3, h1 into e power minus, suppose if you j3 omega by 2 minus j5 omega by 2, so this will be equal to minus j2 omega by 2, so minus omega. So this part, so this term corresponds to this term. Okay, this term h1 e power minus j omega, this corresponds to e power minus j5 omega by 2 into h1 into e power minus j3 omega by 2. Okay, now h1 equal to how much? H of minus h of 1, right? Okay, so h1 equal to h4, so h4 equal to e power minus j4 omega, so h1 into e power minus j omega, okay, so h1 into e power minus j omega means this term corresponds to this, and h1 into e power minus j 3 omega by 2, this one corresponds to this term, e power minus j 5 omega by 2 multiplied by this term. It will be e to the power minus j 8 omega by 2, which is equal to e power minus j 4 omega. All right. So e power minus j 4 omega, and h1 equal to h4. h1 equal to h4 means this is equal to h1. I hope this term is all right. Okay. So now next one is this one, h2 into e power minus j2 omega. So if we multiply these two, a2 e power j omega by 2 and e power minus j 5 omega by 2. If we multiply this will be equal to e power j 4 omega by 2. 4 omega by 2 equal to minus 2 omega. All right. And next one is h of this term, h2 into e power minus j omega by 2 minus. So this will be equal to 3 omega. 3 omega. All right. So this term corresponds to this. So h3 into e power minus j3 omega. This corresponds to e power minus j5 omega by 2 into h2 into e power j omega by 2. So this will be corresponds to h3 into minus j3 omega. Now, if I write the next thing, I can write that h of e power j omega. So e to the power minus j5 omega by 2. So 2h0 cos 5 omega by 2 corresponds to this term. And this is equal to 2h1 cos 3 omega by 2, and this is equal to 2h2 cos omega by 2. All right. So in general, if n is even and hn equal to h of n minus 1 minus n, if this condition is satisfied, then I can write h of e power j omega equal to n equal to 1 to n by 2, 2h n by 2 minus n cos omega n minus 1 by 2 e power j omega n minus 1 by 2. Now see, for n equal to 6, n equal to 6 we are discussing, so this is equal to n equal to 3. Right, the first term corresponds to n equal to 1. N equal to 1 means this will be 2. This is n by 2 means 3. 3 minus 1 means 2h2. 2h2 cos omega, and n equal to how much? N equal to, I said 1. So cos omega by 2.
Omega by 2.
Omega by 2. So see, 2h2 cos omega by 2. And what is the phase? So n equal to 6. 6 minus 1 by 2. So this is 5. So right. Now next corresponds to n equal to 2. N equal to 2 corresponds to 2h1. 2h1 cos omega. So n equal to 2 minus 1 by 2. That is cos 3 by 2.
3 omega by 2.
All right. Next term is n equal to 2. N equal to 2 means this term is 0. I think yes. N by 2. N by 2 means 6 by 2 means 3. So 3 minus 3. So this 2 is 0. 2 is 0 and 3 means in the 6 minus 1 by 2 is 5 cos 5 omega by 2. All right. So this is in general if n equal to even. If n is even and hn equal to h of n minus 1 minus n. This is called symmetric impulse response. Then this will be general expression for transfer function for a given impulse response. All right. So this is one case which is called symmetry thing, and the symmetry, center of the symmetry is n minus 1 by 2. Now what is n minus 1 by 2? N minus 1 by 2 means 6 minus 1 by 2, right? 6 minus 1 by 2. 6 minus 1 by 2 means how much? 2.5, right?
2.5.
2.5. That 2.5 means with respect to 2.5. 2.5 is the center of symmetry. Center of symmetry for symmetric impulse response. Right? Symmetric impulse response. So with respect to 2.5, if you look at these are having equal number of points. Equal number of points with respect to 2.5. 2.5, we are having 3 points left, 3 points right. So we'll say that n minus 1 by 2 is the center of symmetry. Center of symmetry. Okay, one thing what you have to understand that for a given value n, when n is even, in such a case, in general, this will be the expression for transfer function with respect to this condition, symmetric impulse response, and center of symmetry will be n minus 1 by 2. Okay. Now, this is one thing what we have understood. Next, we will see that antisymmetric impulse response. Antisymmetric impulse response. And we have to identify the center of antisymmetry. Again, we will see that n equal to 5 and n is odd here. Now, antisymmetric impulse response, what I understand, that h of n minus 1 minus n, that is equal to minus of hn. Minus of hn. All right. So previously, h of n minus 1 minus n, we have written hn. Now I'm writing minus of hn. That is called antisymmetric impulse response. So therefore, now we are discussing the third condition, right? First, we have discussed n equal to odd and symmetric impulse response with center of symmetry n minus 1 by 2. Okay, so there are two cases, one is odd and even, and we have found general expression. Now we are discussing that antisymmetric impulse response with center of asymmetry, we'll see, but at this stage antisymmetric impulse response, which means h of n minus 1 minus n equal to minus hn. This is the condition. Now in general, for n equal to 5, n is odd, I can write hn equal to this, and h of e power j omega equal to n equal to 0 to 4 hn e power minus j omega. So h0 h1 e power minus j omega, h2 e power minus j2 omega, h3 e power minus j3 omega, and h4 e power minus j4 omega. Now h of n minus 1 minus n, so h of 4 minus n, because n equal to 5, 5 minus 1 equal to 4, 4 minus n equal to minus hn. So h4 equal to minus of h0. If I put n equal to 0, then h4 equal to minus of h0, and h3 equal to, if I put n equal to 1 here, so h3 equal to h of minus of h1, and n equal to 2, h2 equal to minus of h2, which implies h2 equal to 0. What does it mean? Suppose if h3 is not equal to 0, any non-zero quantity, whether it is integer, real or complex, whatever. So any non-zero quantity, it is not possible that positive and negative are the same thing. It is not possible. Therefore, it has to be 0. For antisymmetric impulse response, h2 has to be 0. All right. See, for any real number or integer or complex number, it is not possible that hn equal to minus hn. What I mean, that h2 equal to minus h2 means positive and negative are the same value. Positive and negative are the same value. Minus 2 is not equal to minus 2. 3 is not equal to minus 2. Minus 2.5 is not equal to 2.5. So if both h2 equal to minus h2, that is possible only if h2 equal to 0. Agreed? h2 equal to minus. Suppose x equal to minus x, which means x plus x, 2x equal to 0 means x equal to 0. Is not it? Therefore, if the condition is something that if I put say n equal to 2, it becomes h of 2 equal to minus of h2. So h2 equal to minus h2, that is not possible. That is possible only if h2 equal to 0. Therefore, for antisymmetric impulse response, n is odd. N is odd. Then h of n minus 1 by 2, h of n minus 1 by 2 has to be 0. Agreed? I repeat, for antisymmetric impulse response, which means h of n minus 1 minus n equal to minus hn, for such kind of response, the h of n minus 1 by 2, that has to be 0. Agreed?
Yes, sir.
Very good. So this is one of the important understanding. This is also an important short question as well. Now, we look at what this is important short question means for gate or that level, not in your university level. Anyway, so h0 equal to h of 1 e power minus j omega minus of h of omega e power minus 3 omega h0. How do I have written that? See, h2 is equal to 0. So this part is 0 and h3 equal to minus h1. So let us write minus h1 and h4 equal to h4 equal to minus of h0 minus 0, so I have written minus of h0. Now you write e power minus j2 omega h0 e power minus j2 omega. So e power minus j2 omega, what I have written, because e to the power jn minus 1 by 2 I have written e power jn minus 1 by 2 means 5 minus 1 by 2. So 4 by 2 is equal to e power j2 omega. So this part I have written, and h0, okay, and h0 equal to here. So if I take minus 2 omega, then it will be plus 2 omega, so corresponds to this term. I mean h0 e power minus j2 omega e power minus j2 omega plus 2 omega. This corresponds to first term, and this term corresponds to this term. Minus is this, h0 I have taken common, and e power minus j2 omega e power minus j2 omega e power minus j4 omega. So this term and this term, this two corresponds to this term. Okay. Now, is it all right? Now h1 I have written here h1, so e power minus j2 omega means e to the power j omega. So what I mean that this term h1 into e power minus j omega, this corresponds to this term along with e power minus j2 omega, and this is minus, so I can write that minus of h1 e power minus j3 omega e power minus j omega e power minus j2 omega, that will be there. Okay, I hope this is all right. Next thing that I want to say that if I write this term e power minus j omega e power minus j2 omega, j2 omega minus j2 omega, that is equal to 2j sine 2 omega. Okay, e power minus j theta minus e power minus j theta e to the minus j theta, so that will be equal to 2j sine theta. So that means 2 times j, if I take here, this will be h0 into sine 2 omega h1 sine 2 omega. Now what is the difference between that? Now this j corresponds to a phase term, is not it? Now what is j actually? What is j actually? Okay, j equal to, odd chole geche na, odd. Now j corresponds to e power j, j means e to the power j pi by 2. E power j pi by 2 means e power j pi by 2 means what?
J
j
cos pi by 2
j to, so e power j pi by 2 equal to j, so this will be equal to e power j pi by 2 minus 2j. This time I am not written. What I am saying, e to the power j pi by 2 minus 2 omega. Okay. Is equal to 2 times e power j pi by 2 minus 2 omega. Okay. So this will be equal to h0 sine 2 omega h1 sine omega. This corresponds to this. Now in general, what I can write n equal to 1 to n by 2, 1 to n by 2, because here what is the value of n? N equal to
5.
5. Now I think this is not, this is page 3, this one is page 1. So page 2 I didn't scan. Page 2, 1 minute. Page 2 টা তো স্ক্যান করা হয়নি। Okay, just 1 minute. Okay, so here what you have to see that this is not this is corresponds to page, the page 2 I didn't scan. So what we have to write, this was, what is the expression? It will be the expression e power j pi by 2 minus 2 omega, e power j pi by 2 minus 2 omega, and h0 into sine h1 minus omega. তাহলে সামেশনটা কি হবে বলো দেখি? Summation, what will be the summation? Summation will be summation will be, if you see here, n equal to 5, n equal to 5, n equal to 1 to n minus 1 by 2. Suppose this term is 0. If this term is 0, then n equal to 1 to n minus 1 by 2. So n minus 1 by 2 কত হবে বলো তো? What is n minus 1 by 2?
2.
2. তাহলে this term will be n equal to n minus 1 by 2, 1 by 2, 2h n minus 1 by 2 minus n sin omega n, and e power j omega pi by 2 minus omega n minus 1 by 2. You check whether it will be that or not. E power, suppose h of n minus 1 by 2 টা 0 হলো তো, this term will be 0. See this one, n equal to 5, n equal to 5, h2 becomes 0. If h2 becomes 0, then what will be this term? H0, this will be sin 2 omega and h1 equal to sin, just 1 minute, আমি এটা add করছি. Yeah, now see page 2 now. Okay, so page 1 you have seen. So e power j pi by 2, e to the power j pi by 2, this is equal to j, right? This is equal to j. Now you can see n equal to 1 to n minus 1 by 2. N equal to 1 to n minus 2 means how much? N equal to 5. Then n minus 1 by 2?
1 to 2.
2. 1 to 2. 1 to 2. তাহলে n minus 1 by 2, that is equal to 2. Yes? So 2 minus n sin omega n. তাহলে দেখো তো এটা ম্যাচ করছে কিনা? Now if I
2h1 sin omega n. Yes.
ম্যাচ করছে? This is equal to h0 তো, তাহলে h0 sin 2 omega, h1 sin omega. তাহলে if you look at here, so if I put n equal to 1, so 2, n equal to 1 means 2h1, 2h1 sin omega. Yes? And n equal to, if I put 2, so 2h0 sin 2 omega.
H0.
Huh?
Yes.
2h0 sin 2 omega.
Yes.
Okay.
Yes.
Next part will be e power j pi by 2 minus omega into n minus 1 by 2. All right. তাহলে ফেজটা হয়ে যাবে e power j pi by 2 minus omega into n minus 1 by 2. So n minus 1 by 2 minus j power 2 omega, n equal to 5, and e power j pi by 2 equal to cos pi by 2 plus j sin pi by 2, which is equal to j. Therefore, if impulse response is antisymmetric, and center of antisymmetry, and the center of antisymmetry, if the center of antisymmetry is n minus 1 by 2. Now what is n minus 1 by 2? Is n minus 1 by 2 equal to 2?
Hmm.
So with respect to 2, you are having equal number of points. Because with respect to 2, you are having equal number of points, because n equal to 0, n equal to 1, n equal to 3, and n equal to 4. So like 3, 4 with respect to 2 is the right side, and with respect to 2, 0, 1 in the left side. Agreed?
Yes.
So from this, what we have concluded that if the impulse response is antisymmetric, then the center of antisymmetry, that means h of n minus 1 by 2, this is equal to 0. This is equal to 0. This is one observation. And second observation is it is the antisymmetric, and center of antisymmetry will be n minus 1 by 2. And value at the center of antisymmetry, that will be equal to 0. And in general, for n equal to odd, this will be the expression. If n equal to odd, this will be the expression. Now, another important observation from this, for antisymmetric impulse response, that means h of n minus 1 by 2 minus hn, which means that h3, h4, the amplitude reversal is there. That means the time domain signal value, they are multiplied by -1, is not it? And corresponding effect in the frequency domain is an additional phase pi by 2. Have you followed? The effect of antisymmetry. This is another important short question for GATE or other exam. That the effect of antisymmetry, two effects. One is center of antisymmetry, the value at the center of antisymmetry, that will be equal to 0. And the effect of antisymmetry in the frequency domain is multiplication of additional phase pi by 2. Agreed?
Yes.
Very good. So these are the two things. Next case,
Sir.
Tell me.
Sir, secondary point একবার বলুন।
Second point হলো that effect of antisymmetry in time domain, the corresponding effect in frequency domain is the multiplication of a phase factor e to the power j pi by 2. In other words, an additional phase factor introduced in the Fourier transform, discrete time Fourier transform, due to the antisymmetry. Agreed? I hope it's all right.
Yes, sir.
Very good.
Yes, sir.
Now next we are discussing, so that is what we are discussing, n equal to odd. Now we'll take the discussion on n equal to even. Now if we take n equal to even, so n equal to even, n equal to 6, again we will assume antisymmetry. Antisymmetry means h of n minus 1 minus n, this is equal to minus hn. Now if n equal to 6, so we will be having 5 values, h0, h1, h2, h3, h4, h5. Okay, h5. Now h of n minus 1 minus n equal to minus hn. So if I put n equal to 5, sorry, n equal to 6, so it will be 6 minus 1, 6 minus 1 is 5, h of 5 minus n equal to minus of hn. Now if I put n equal to 0, so this will be equal to h5, h5 equal to minus of h0. Then n equal to 1, h4 equal to minus of h1, and n equal to 2, that will be equal to h3 equal to minus of h2. Now, in case of even, that no filter coefficient is 0. So that is one difference between
Yes.
odd and even. In case of odd, center of asymmetry becomes 0. But here, no filter coefficient 0. All filter coefficients are non-zero. Okay. Now, if I write the h of a power j omega, this will be equal to h0, h1 e power minus j omega, h2 e power minus j2 omega, h3 e power minus j3 omega, h4 e power minus 4 omega, h5 e power minus j omega. For n equal to 6, corresponding value of n equal to 0 to n5. Now again, first I am taking out e power jn minus 1 by 2. This phase I am taking out. Now h0 e power j5 omega by 2, e power j5 omega by 2. This corresponds to this term h0, means if I write e power minus j5 omega by 2, then h0 into e power j5 omega by 2. Then h0, if we look at here, h0 equal to minus of h5. So this term h5 equal to minus of h0. So this term h0 into minus e power minus j5 omega by 2 into e power minus j5 omega by 2, this corresponds to the term h5 e power minus j5 omega. Is it all right?
Yes.
I hope this is all right, because e power minus j5 omega by 2 and e power minus j5 omega by 2, if you multiply this term, it will be e to the power minus j5 omega, and h5 equal to h minus of h0. If I substitute, then these two terms, if I combine, I will get this term. Okay. Next corresponds to, who is this person? Another one person has admitted. I don't know who is it. Anyway, h1 equal to, say, this one. This one is e power minus j3 omega by 2. This term corresponds to, so h1 means e power minus j omega. So if I multiply h1 into e power minus j3 omega by 2 with e power minus j5 omega by 2, this corresponds to h1 into e power minus 2 omega by omega, corresponds to this term. Okay. And h1 equal to h4. So h4, so it is negative sign. So I have written negative sign. Now e power minus j4 omega, this corresponds to e power minus j3 omega by 2 multiplied by e power minus j5 omega by 2. This corresponds to term h4 into e power minus j4 omega. All right.
Yes, sir.
Yes.
Okay. Now, if I look into this term h2 into e power minus j2 omega, if you multiply h2 into e power minus j omega by 2 into e power j5 omega by 2, this corresponds to h2 into e power minus j2 omega. Agreed? Because
Yes.
minus j5 omega by 2 plus j omega by 2, this corresponds to this term. Now, if you look at h2, and again, if you look at h3 equal to minus of h2, h3 equal to minus of h2, so this term equal to h3 into e power minus j3 omega. So this term corresponds to this. Okay, because if you multiply this term, h3 equal to minus h2, so this term h3 into e power minus j3 omega, this corresponds to h2 minus e power minus j omega by 2, this multiplied by e power minus j5 omega by 2. Okay, this term corresponds to h3 into e power j3 omega. Now again, if you come write down, so this again equal to 2 times, now h0 sine omega, here you will be having one j, right? No, j is included here. Okay, fine. So this, if you write cos, this is equal to sine 5 omega by 2, this is equal to sine 3 omega by 2, this is equal to sine omega by 2, and multiplication of 2j. So 2 I have written here, and j corresponds to e to the power j pi by 2. So here e power j pi by 2 minus 5 by 2 omega into this term. This will be the expression for h of e power j omega. Now coming back to this previous note where I have missed the page 2, now I have to go to page 3, right? Page 3. So page 2 I have to insert in between, I have forgot. Okay, so page 2 means this one. this one you are having this expression. So H0 sine 5, H1 sine 3, and H2 sine omega by 2. This is the expression for n equal to 6. Now for in general, what will be the expression? In general, the expression will be, see, e power j 5 by 2 minus omega, n minus 1 by 2 means n equal to 6. 6 minus 1 by 2 means omega 5 by 2. That is okay. E power j pi by 2. Now let us see the phase. Here also e power j pi by 2 minus 5. So for general, it will be e to the power j pi by 2 minus n minus 1 by 2. All right. Now, next is this chart. If I put n equal to 1, what is the value? See, n by n equal to 6 means n by 2 minus 3. Right. So this expression n equal to 1 to 3. So now if I put n equal to 1, n equal to 1 means 3 minus 1. 3 minus 1 means 2. So like 2h2 sine omega by 2 or sine omega by 2 sine omega by 2 n equal to 1 omega by 2 তাহলে কি আছে এখানে কি আছে দেখো তো এখানে এক্সপ্রেশনটা কি আছে টোটাল সি if you put n equal to 1, same thing, sine omega by 2. Now if you look at the page 2, see, sine omega by 2 and 2 is multiplied here. Agreed?
Yes, sir.
All right. Now h1 sine 3 omega by 2 and h0 sine 5 omega by 2. Now let us see here. If I put n equal to 2, n equal to 2 means 2h1. 2h1. Or if I put n equal to 2 here, so there it will be 2h1 and sine what হবে এটা 2 minus 3 omega by 2
3 by 2
3 omega by 2 ওখানে কি আছে what is here page 2 if you look at 2h1
3 omega by 2
3 omega by 2. Now if I look at the n equal to 2, n equal to 2 means 2h1 n equal to 3 n equal to 3 means 2h0 2h0 sine
5 omega by 2
sine 5 omega by 2 sine 5 omega by 2. So if you look at here 2h. All right.
Yes.
So what I have to do now, see if in this page 2 is missing in this lecture. This page 2 is not there. I have to insert page 2 in between and I will send it to you. All right. Now,
Yes.
another important conclusion at this stage, what I would like to mention that in case of n is even, then the effect of antisymmetry in time domain, corresponding effect in the frequency domain is the additional phase pi by 2. So an additional phase is introduced corresponding to the effect of antisymmetry in case of n equal to even. Right. Therefore, today what I have discussed that, and also another important thing, center of antisymmetry. Now, what is the center of antisymmetry? N minus 1 by 2. N minus 1 by 2 means 6 minus 1 by 2. 6 minus 1 by 2 means
5 by 2.
5 by 2. That is
2.5. 2.5.
With respect to 2.5, if you look at the left hand side and right hand side, you are having equal number of points. So center of antisymmetry, if we look at the center of antisymmetry, with respect to center of antisymmetry, that is 2.5. With respect to 2.5, you are having again equal number of points. With respect to 2.5 is in between. Equal number of points h0, h1 and h2 in the left hand side and h3, h4, h5 in the right hand side. With respect to center of antisymmetry, which is n minus 1 by 2 in general, equal number of points. So whether it is symmetric or antisymmetric, with respect to symmetry or with respect to antisymmetry, you are having equal number of points. Only difference is in case of antisymmetry, even or odd, in every case we are having additional phase pi by 2 in the frequency domain. And another important thing, in case of n equal to odd, your center of antisymmetry, it becomes
It's 0.
0.
0.
This is what I have said. We are having less than 1 minute. I hope you have understood. So if you have any doubt, you can ask in less than 1 minute, or I would like to stop for today. All right.
Yes.
If you have any doubt, I hope everything is all right. Okay. So tomorrow again we will take the class and we will discuss some other things like center of antisymmetry around origin. That will discuss on new things tomorrow. Okay. Until then, thank you.
Okay. Thank you, sir.
Thank you, sir.
Thank you,
Thank you,
sir.
sir.